Alright, so now we want to talk about two of the main rules that we have when working with radicals. The first one is the product rule for radicals, just like we had product rules for the product rule for exponents. Okay, and this is what you're going to see when you have the product rule for radicals. Okay, the nth root of a times the nth root of b is equal to the nth root of a times b. Okay. The things we want to point out here, we want to stress to you is the following. You have to have the same index. Okay? As long as the index is the same, then you can combine this as one radical. Likewise, you can split it up. Okay? We're so used to seeing the equal signs as going in only one direction, but you could also come back this way if you needed to. Okay, and we'll be seeing that probably a lot more than going that way. Okay, but at the same turn, we also have the quotient rule for radicals. Okay. So the quotient rule for radicals is probably exactly what you would expect it to be. If I have the nth root of a divided by the nth root of b, I could write this as one single fraction as the nth root of a over b. Again, you notice that we have to have the same index.
That's kind of like just what we just got through doing. Well, as far as the.
Well, it's not what we just finished doing, because the problems that we just had different indices. They weren't the same kinds of radicals. Like you had a fourth root and a cube root. So we had to convert those guys to exponents first before I could do anything with them. But you know what? When you were getting common denominators, so back over here, when you got a common denominator of 10, we said that the denominator matches up to the index, right? So getting a common denominator here was basically like getting common indices there. Okay, so then you could do that in a way using the product rule, the quotient rule for radicals. Okay, but really, when we have these guys set up, it's really for the purposes of going the other direction. Let's just work through a few examples so you can kind of see what's going on here. For example, I could ask you to simplify the cube root of 5 times the cube root of 2. According to the product rule for radicals, what would I get here?
Cube root of 10.
Right. You start with 2 cube roots, and so you can multiply the radicands and just get the cube root of 10. That's it. Okay. We even had something, we didn't really use this as the quotient rule when we had the problem before. I think a problem that we did on the board was this. The square root of 100 over 169. Now what we could do here is we can use that quotient rule to break this up. And we can say that this is really the square root of 100 over the square root of 169. You keep the index the same, so it's still a square root. But maybe by splitting it up like this, it's easier for you to do each of these pieces. So you can tell me, what is the square root of 100? What's the square root of 169? No, it's 13. Now, did I need to separate that like that? Did I need to do that? No. But you see kind of how it works, how that quotient rule doesn't change what we've been doing. Okay. What do you guys think about that? You know, this is, let me again show you something that you guys are already familiar doing. If I have the fourth root of 16, x to the 20th, y to the 44th and a to the 32nd. This is something that we should be able to knock out very quickly when we realize that this is all multiplication between those terms. Now, even though we probably would not write it this way, because there's not really a need to, you could write this as the 4th root of 16 times the 4th root of x to the 20th, and so on, right? You could actually separate into all of these different factors. Now, do you think this is something that I'm going to do? No, for me, there's no need for doing that. And really, even for you, there's no need for you to do that. What's the 4th root of 16? How about 2? What raised to the 4th power is 16? I didn't say divide 16 by 4. What's the 4th root of 16? The answer is 2. Right? What's the rest of this?
X to the 5th.
That gives me x to the 5th.
X to the 11th.
Nope. Y to the 11th.
Oh, I'm sorry, Y to the, excuse me.
And then what?
A to the 8th.
A to the 8th. What do you guys think about that? Awesome? Guess I just need to box this so we can all be happy, right?